Halogenation of alkynes. Alkynes react with one equivalent of halogen in the presence of dichloromethane as solvent to give dihaloalkene. So this is a dihaloalkene, which is a product in the first electrophilic halogenation. Okay, this dihaloalkene can further undergo electrophilic halogenation, electrophilic addition reaction with halogen to form the tetrahaloalkane. So when you use two equivalents of halogen or excess of halogen, then it's going to go form the tetrahaloalkane as a product. The mechanism for this reaction is pretty much similar to what we have seen in the case of halogenation of alkenes. Since we are starting with an alkyne here, it's going to form a pi complex, which is going to look like this. Right? And once the pi complex is formed, the Cl minus is going to go and attack in a direction that's opposite to that of this three-membered ring structure. And since we have a symmetrical alkyne, this Cl minus can go and attack on any one of these carbons and break open the ring. So it can go in this direction, or it can also go and attack this carbon and form the product. The product here will have the two chlorines in the opposite direction, and therefore this is going to be anti-addition. The second electrophilic halogenation reaction also happens exactly in the same way, where again it's going to form the chloronium ion, and the Cl minus is going to go and attack in a side that's opposite to that of the three-membered ring structure and break open the ring. Okay, so here in this case it's going to form the tetrahaloalkane, and you can see that these are the two chlorines which are added in the first electrophilic addition reaction, but here are the two chlorines which are added in the second electrophilic addition reaction. And you can see both of those two sets of chlorines are opposite to each other. In the case of unsymmetrical alkyne, the incoming nucleophile has got a preference. So here, if you take a look at this, this is an example for an unsymmetrical alkyne. Here again, it's going to form the pi complex. So the pi complex is going to look like this, right? So this is bromination, and therefore this is going to form the cyclic bromonium ion. Once the cyclic bromonium ion has been formed, the Br minus is going to go make a nucleophilic attack on the most substituted carbon. So between these two carbon, this is the carbon which is highly substituted. So this Br minus will go and attack this carbon, and it will break open this ring to form the product. And the second electrophilic addition reaction can also happen to give the tetrahalo substituted product.